Go.
Okay, our topic for today in Science 12 is about electronics. We have here a diagram of 6 resistors that are connected. The 3 resistors in parallel and 2 resistors also in parallel, and one resistor that are connected in series with the 2 parallel resistors. Okay. We are now going to solve for the following: the R total, the I total, which is the total current, and the individual current I1 to I6, and also the individual voltages V1 to V6. Okay, solution RT. We are going to start from the farthest part of the circuit. In solving for a combination of parallel and series, we are going to start at the end part of the diagram, which is R5 and R6. The total of R5 and R6, since they are connected in parallel, therefore there is a reciprocal, R5 and R6. 1 over R5 6 will give us the reciprocal of R5 plus the reciprocal of R6. Okay. 1 over R5, 2. 1 over 2 plus 1 over 6 is 1/4. 1/2 is equal to 0.5. 1/4 is equal to 0.25. And the total is 0.75. Now we are going to solve for the R56. R56, removing the reciprocal, will give us 1 over 0.75, which is 1 divided by 0.75 is 1.333. Okay, ohms. Now I'm going to record this data for future record by and by as we go on with our solution, which is 1.333 ohms. Okay, we were able to solve for R56 here. We were able to combine R5 and R6. And if we are going to simplify this diagram, here are the 3 resistors. I will leave it vacant. And R4 here. And another resistor that are being combined with each other, which is R5 and 6. This is R4. Okay. Now, we are going to solve for the resistance here, R1, R2, and R3. R1, R2, and R3. By the way, what are the connections of these 3 resistors? They are also connected in parallel. And therefore, we are going to solve for R1, 2, and 3 with a reciprocal. It's equal to 1 over R1 plus 1 over R2 plus 1 over R3. Giving us 1 over R1 is 3, 1 over R2 is 5, 1 over 5, plus 1 over 3 is 1 over 4. Will give us 1 over 3 is 0.333. Is it 1.333?
Okay.
1 divided by 1 divided by 3,
1 divided
0.333.
0.333.
Okay. We are going to get 3 digits after decimal point. 1 divided by 5 is 0.2. And 1 divided by 4 is 0.25. Okay, adding these values of the individual resistance, we will have a total quotient of
0.78.
0.783. Now we are going to solve for R, 1, 2, and 3, removing the reciprocal. is equal to, removing the reciprocal of R123 will give us 1 over 0.783. Okay. The quotient will be 1 divided by 0.783, and we are going to record this value 1, 2, and 3.
1.27.
1.27 ohms. Okay, now we are now able to combine R123 in one resistors or resistance only in a diagram. This is now R1, 2, and 3 having a value of 1.27, R4 as 2 ohms, and R5 and 6 as 1.333 ohms. Okay, we are now going to get the total resistance since all resistance are now involved in the series and they are connected in series. We can now solve for the R total. R total, since they are now connected in series, don't have a reciprocal. Therefore, R total is equal to R1, 2, and 3 plus R4 plus R5 and 6. Okay. R1, 2, 3. Okay, 1.27. Plus R4, 2. Plus R5, 6. 1.333 will give us a total resistance of, okay, how much? 1.27 plus 2 plus 1.333,
4.603.
4.6 to
603.
603. 4.603 ohms. That is the total resistance. We were able to solve one unknown, which is the R total. R total is 4.603 ohms. Now, we are going to solve for I total. The I total. I total, using the general formula of Ohm's law, is equal to the voltage total over the solved R total. Voltage total is 100 volts over the total resistance, which is 4.603 ohms, will give us 100 divided by 4.603,
21.72.
31,
21.72.
21.72 amperes. That is the total resistance. I'm now going to record this also. 21.72 amperes. Okay. Let us continue with our solution. We are now going to solve individual currents and individual voltages. Since we were able to solve the total resistance, total current, and the total voltage is known to be 100 volts. Okay. Using the general formula for series, since we were able to simplify the circuit into a series connection. R123 is connected with R4 and R56 in series connections, one direction. Meaning, we are now going to use the conditions of currents in a series connection, which is the I total here will be the same as I1, 2, 3 equals to I4 equals to I5 and 6, which is 21.72 amperes. Okay, now we are going to solve for V1, 2, 3, since we have the I23, V1, 2, 3, using this general formula, I1, 2, 3, multiplied by R, 1, 2, 3. Okay. I1, 2, 3, 21.72 amperes. And R1, 2, 3 is, okay, 1.27. ohms. Okay. Value. What is the value for V123?
27.584.
20,
7.584.
27.584
84.
volts. Volts. This is volts. Now, knowing V123, in parallel connection, V123 here is 27. Should the voltage here at R1 should also be 27. Voltage here should be also be 27.584, and B3 is also B 27.584, since they are all connected in parallel, because parallel connection will give us a common voltages. Therefore, V1, 2, 3 will give us B1 equals B2 equals B3 equals 27.584 volts. Okay. Therefore, we were able to solve the individual B1, B2, and B3. Also the B4. Okay. What now the unknown will be I1. Okay, we are not going to solve for I1 since we have B1. I1 using the general formula is equal to V1 over R1. Remember the principle that if we use the 1, all other terms should be 1, 1. If we use the 1, 2, 3, the other terms should be 1, 2, 3. 1, 2, 3. Never that other subscript will be different from others. If we use 1, all should be 1. Okay. B1 is equal to 27.584 divided by R1, which is 3. Okay, this is I1. 27.584 divided by 3.
9.194. 194.
9.194 amperes. And I2 is equal to B2 over R2, following the principle of 2, 2, 2, 2, 2, and 2. B2, the same with B1 and B3, 27.584 divided by R2,
5.
which is 5. Which give us
5.516.
5.516
516.
amperes. Okay. By and by, we are going to solve, add all the currents here, I1, I2, and I3 here. The total should be the total current, since the formula that we have here is IT should be equal to I1, 2, 3. And the total currents here will be added. Current 1, current 2, and current 3 will give us a value of 21.72. Let us see if we are correct. Okay, we are now going to solve for I3. I3 is equal to B3 over R3. V3, do we have the value of B3? Yes, 27.584 divided by R3 is 4. Will give us the value of
6.896.
6.896
896.
amperes. Now, we are going to check. This is the checking if we are correct with the solution, giving us a value of I1, I2, and I3 to be 21 as the formula given to be IT is equal to 1, 2, 3. Okay, 9.194 plus 5.516 plus 6.896.
21.60.
Yeah, 21 point. That is correct already. We have the 21.61.
61.
Okay. Since we have the first two numbers to be 21, it is already correct. Okay? I'm now going to erase this I1, I2, and I3. Okay, B1, B2, B3. Now, what we are going to solve is the B5 and 6. Okay, B5 and 6. I'm now going to raise this one. V5 and 6 or the individual voltages at 5 and 6. B5 6 is equal to I5 6 times R5 and 6. Do we have the value of I5 6? I5 6 is IT is equal to IT. A while ago, we were able to solve for the IT, which is 21.72 is also equal to I1, I123 is also equal to I4 is equal also to I5 and 6, which is 21.72 amperes. Now, we are going to use that value of I5 and 6, which is 21.72. 21.72 volts multiplied by R5 6, which is 1.33. 1.333 will give us the value of voltage 5 and 6 to be 21.72 plus times 1.33,
28.95.
28.95
95.
volts. Okay, V5 and 6 is equal to, since these two resistance or resistors 5 and 6 are connected in parallel, the voltages here are equal. Therefore, V5 6 is equal to V5 is equal to V6 is equal to 28.95 volts. Okay, we are now going to solve for the individual current. A while ago, we were able to solve for V1, V2, V3, I1, I2, I3. This time, we are going to solve for I4, 5 and 6. I5 and I6. By and by, we are going to solve also the voltages. Voltages here, and voltage here. The sum of these all voltages should be equal to 100. Okay. I5 is equal to B5 over R5. Giving us a value of B5 is 28.95 volts all over R5, which is 2. Okay. Value is 28.95 volts divided by 2 ohms.
14.475.
14.475
475.
amperes. Okay. And I6 will be B6 over R6. B6,
1.95.
the same with the B5 and 5 and 6 is 28.95 volts over R6, which is 4 volts, 4 ohms, will give us a value of
7.237.
7.238
238.
amperes. We are going to check if I5 and I6 will give us the same value with I total, which is 21.72. Okay? 14.475 plus 7.238. If our answer will give us 21.72, then our solution will be correct.
21.71.
Okay, 21.71 is already accepted as correct. Okay, therefore, individual I5, I6 has been already solved. I1 to 6, approved na. V1 to 6 is also being solved. Now we are going to check the voltages here, which is B1, 2, and 3 is equal to. Can we find the value of the voltages there? B voltages 1, 2, 3. Do we have the solution? A while ago, we will solve the value for this voltage 1, 2, 3. Voltage here before. If none, then we are going to solve again to check, because our blackboard or the whiteboard is limited. Therefore, we are going to solve it again. Okay, B1, 2, 3 is equal to I1, 2, 3 times R1, 2, 3. I1, 2, 3, the same with
I total.
21 I total. Therefore, 21.72 times R123 1.27 will give us how many volts?
27.584.
27.584. And we are going to check. This is the final check. If B123 here, the voltage here, plus the voltage here and the voltage here will give us a 100 volts, then our solution is correct. Okay. B4. We can solve now for B4. I4 times R4. Do we have the value of I4? I4 is do we have the value here? I4, this one, 21.72. 21.72. R4, 2 ohms will give us
43. 43.44.
3.44 volts. And lastly, B5 and 6. V5 and 6 will give us I5 and 6 and R5 and 6. V5 and 6, R5 and 6 is, do we have the value for R5 and 6? Yes, this one. 21, which is V5 and 6 will give us the value of I5 6, which is 21.72 times the R5 6, which is 1.333 ohms. Okay. Will give us the value of
28.95.
28.95 volts. Now we are going to check. This is now the final computation. If we are correct, then we can prove that V123, B4, and B56 should be equal to 100 volts since they are connected in series. Nag-a-add yung mga voltages in that connection. Okay? We're going to start with 7.584. Plus this one, B4, 43.44, plus the B56, which is 28.95 volts.
99.97%.
Okay, 99.97 is very correct, which is if we are going to round it up, we will get 100 volts. Okay, sige. That's up for today. Ayos na yan. Yan ay